So let's take a step back and let's once again talk about the parts of a biomedical instrument, an instrument specifically used for measuring something, right? And this is, I'm going to keep showing you the same cartoon, right? The more I show it to you, the more it will make sense, right? You have a sensor, you have a circuit, and you have a display. And no matter how complicated a medical instrument seems to be, right, you can look for these components in it. Now, the thing that you are measuring, right, could be temperature, maybe it's blood glucose, maybe it's brain activity. We'll talk about all these ones and so on. Activity. Right. And the list goes on and on. We're going to start to refer to the thing that you are measuring, whatever it is, as the measurand, right? Which we can define as, in a very technical definition, the thing you are trying to measure, right? A very technical definition. The term measurand is actually not something I see very often outside of courses like this, right? And I hate to introduce terminology, but I also hate to keep saying the thing you are trying to measure, the things you are trying to measure. So we're just going to refer to that as the measurand from now on. Sounds good? Now, on the display, of course, right? What should be on the display? Well, it should be a indicator of the measurand. Now, here's the first use of that term. Seems very obvious. A temperature meter, right? Senses temperature and displays that on the screen. A glucose monitor, right, is ultimately going to be showing that on the display. Seems very obvious. All right. Now, we started to talk about the sensor, right? And we talked about a resistive sensor, a type of sensor that is a resistive sensor, right? And now I will define that as, I'll just write it like this, a resistor whose resistance, and here's that term again, is a function of the measurand, right? So we have and it's still a physical resistor with two ends on it, right? However, its resistance is a function of the measurand. And specifically, up to now, we talked about resistive temperature sensors, right? So here we have resistive temperature sensor, by which we mean, right, this would be a type of resistive sensor, by which we mean the resistance is a function of temperature. And you could say, so resistive temperature sensor. All right? I want you to think of this as the sensor converts the, again, here's that word, measurand, into resistance. Saying the same thing over and over again, right? Nothing's different here, right? But now we can start to define what we mean by a sensor. And here I want to be specific here that this is a definition for a resistive sensor. A resistive sensor is something that takes your measurand, whatever it is, right, and converts it, this is a more general point, and converts that measurand into a resistance, and therefore, a resistive temperature sensor converts our temperature measurand into resistance. This is putting into words, right, taking things we've already talked about, but now we're putting it, in context. Okay. And all this was about the sensor here. We have learned that you can't just, stare at a resistance and know what its resistance is. And so when we're building these instruments, all instruments, the sensor, including in this case a resistive sensor, needs to be connected to a circuit. Let's go here for that. And the most basic circuit, the essential circuit that we talked about had a voltage source, a resistance that is fixed, and let's use the square around here, and a resistance that is the sensor. And we can measure the voltage, let's call it Vs, across this resistance. So we have the sensor, two wires, these two wires, included in a circuit, and now we get, and here's your voltage divider equation that hopefully is familiar, is E is equal to R sensor over R sensor plus R fixed. Okay. Now, for this process to be quantitative, we don't just need to know that the sensor converts the measurand to the resistance. We need to know how. We need an expression for this, right? Let's imagine that we're still thinking about temperature. And I'm going to say that this particular resistor, I'll call it RT, is equal to something very simple. Let's say alpha times the temperature. This is the measurand, and this is some constant. 10, right? 10. So if the temperature is 20 degrees C, let's say this is in C, right? Then this is going to be 200 ohms. And if the temperature is 100 degrees C, right, then times 10, we're going to get 1,000 ohms. Different resistive temperature sensors come with different equations with different constants. And we talked about thermal resistors that have an equation closer to this. And we've talked about thermistors that have a different equation. At the conceptual level, however, I don't want you to worry about the equation, all right? If I change this equation and I put a squared here, fine, right? It doesn't change anything conceptually about what's going on, right? It's just another equation. Provided this equation and this equation, we have everything that we need, right? And the way we approach this problem is by identifying that this is something that we measure. This is known. This is known. And so I'll put, a line over the unknowns, right? There's only one unknown here. How do we measure this? we have a display. And in the final stage, right, we will take our voltmeter and we will measure the voltage. So that's what I mean by measure, right? I'm using it as an analogy for what's here in the display. So we measure something. Maybe we measure 5 volts. Maybe we measure 1 volt. However, the point of our device, of course, is not to tell the dad worried about whether his son has a fever 5 volts, right? The dad needs to know the temperature. So there is a step missing here, right? Where we have to take, and that step, as you now realize, is to then apply this equation in reverse. Since we measured the voltage, we know the battery voltage. Why? Because we designed it. We picked it to be something. We picked this resistor too ahead of time. We can calculate what our sensor is using the voltage divider equation, and we'll get some value in resistance. Maybe it's 2 ohms. Maybe it's 1,000 ohms, right? And then we will go to this equation here, and then we will plug in 1,000 ohms here. We know what this is, right? Because we picked this instrument, and now we have to solve for one unknown. So what I'm trying to convey to you here is that there is always 2 equations in play. The equation for the sensor and the equation for the circuit. When we're designing things, we are moving in this direction. But at the final stage, where we are decomposing the voltage into the thing we measure, we go in the opposite direction, right? And that is conceptually what we've dealt with so far. If I were instead to give you a resistive sensor that, let's say, changed with something else. So I'm going to give you a hypothetical resistance that is a function of blood glucose. Doesn't exactly work this way, but it does, let's say hypothetically. And moreover, I gave you an equation, right? I said that R sub G is equal to the concentration of glucose, right, times 7 and whatever. Put this to the 3rd power. It doesn't matter. If I gave you this sensor and I told you to make a device that could measure glucose, let's say in a liquid, water, or in blood, you have the principles in hand. You would take the sensor, right, and you would put it into a circuit. What circuit? The same circuit. Always the same circuit. The voltage divider, right? Now, pick your battery carefully. We talked about that last time. Pick your resistor carefully. You've been thinking about that a bit, right? We'll talk more about that today. And measure the voltage. And once you measure the voltage, you back calculate. And so you see how one principle can actually cover all biomedical measuring instruments with art, with nuance that we're going to be talking about. But the rest of this course is just nuance. It's just variations on the theme. Any questions on that? Yeah.
So are we also mainly doing resistive sensors throughout the course?
So the question is, are we only doing resistive sensors? No. We will do things called capacitive sensors and light-based sensors, but they will be permutations on the rule rather than, this will not change. We'll maybe add things to it. And the circuit may be updated. But you know what? We're only going to leave voltage divider when we really need to. And we're gonna hang on to that voltage divider for as long as we can. There will be, you are correct though, we will introduce some other circuits, but they'll also be very generic and very broadly applicable.